Hi, I'm Hadrian Da Vinci, and today we're using Scikit Learn to do linear regression. Now, before we get started, let's discuss the background. So linear regression is taking some data set and finding the best straight line such that the distance from every point in that data set is minimized. So now that we have an understanding of what linear regression is, let's get started. The first thing that we're going to do in this example is we're going to load our libraries. So load libraries. This is where we'll load Scikit Learn, Matplotlib, and also NumPy. So we'll do import NumPy as MP. Then we'll do import Matplotlib. As PLT. And then also we'll do, we'll import Scikit Learn. So we'll do import sklearn. And from Scikit Learn, we're importing the linear regression library. So we have that here. We're going to import this as linear regression. All right. Now, what I'm going to be doing here is that for every single Jupyter cell, I'm going to run that just to make sure that I don't make any typos because I'm human. So let me run this by doing Shift-Enter, and okay, great, no errors. If there were errors, you guys would see things pop up in red and it would complain. All right, so now that we've loaded those libraries, the next step is to define our input. So this input could be any data set. In this particular case, I'm going to choose certain numbers that I know just work, but if you're working with various inputs, you can actually use that here, right? So define inputs. Or define input data set. And this is Markdown. Okay, so in this case, I'll have X be a NumPy array, so MP array, and let's choose these points. We have 5, 15, 25, 35, 45, and 55. And then for our y's, we'll have another array. So do note that here we're using NumPy arrays as our input. We'll have 5, 20, 14, 32, 22, and 38. All right, let me make sure that these numbers are what I want. Okay, looks good. And that looks good. All right, perfect. And I'm going to run this cell with Shift-Enter. Okay, no issues there. So the next thing that we want to do is we want to reshape X. One of the things that is very particular about Scikit Learn is that it expects your X variable to be a list of lists. So we have to reshape it. Right now it's just a one-dimensional list. So we're going to reshape our X. Reshape X variable. And this is Markdown. And we'll do that by, we'll say X is equal to reshape. And here we'll pass -1, 1. Oh yeah, I forgot this. So we're modifying X. So X is equal to X.reshape. Perfect. All right. Now after we have reshaped X, we can then take our X and take our Y and then use that to create our model. So let's do that. Create model from dataset. And here we'll do model is equal to linear regression. And we're going to pass in our x's and y's. And this should work. Let's try this and see if we have any errors. Okay, good, that works, perfect. All right, so now that we have our model, this is actually what we can use to generate our y's. So let's look at constants. And I'm going to print the slope. So we'll do print, let's see. So m represents the slope, and we'll do our model dot coefficient. So when we type this, we're telling Python to take our predictive model and then show us the slope. Because keep in mind, again, we have y is equal to mx plus b, and we can find out the actual slope of this particular line. Then also, I want to find what is the y-intercept, and we can do something very similar. So we'll do b, which is the y-intercept is equal to the model dot intercept and underscore. One of the questions that you may have right now is why use underscore? It's because we're telling Scikit Learn here that this is an estimate. So we're not getting the exact number. This is just an approximation of that actual intercept. In a similar fashion, this is an approximation of the coefficient. Let's run this. Perfect. So according to this, it says that my slope is 0.54 and my y-intercept is 5.63 repeated. Good. So now that I have this, let's look at the coefficient of determination, which is also called R. And R represents how close or how good of a model you have. So the closer R is to 1, the better fit your model is, the better your model is. And let's see, we'll write determine R. Okay, so we'll print R squared is going to be, let's see, what I'm going to do here is I'm going to define a variable because I'm trying to keep the code nice and clean. So let's just call this R2 is equal to the model dot score, and here we're passing in the x and y, and then here when we're printing that value, we're actually printing R2. So that way it's going to be a little bit easier for us to read later on. Now let's run this and see if we have any errors. All right, perfect. So what this tells me is that the coefficient of determination, aka R squared, is 0.74. So this is not really the best fit. It's okay, but it could be better. Okay, so now that we have our coefficients, let's look at a plot. In order to do that, we have to create some predictive values. So what I want to do is I'm going to actually create a new set of x's. And let's do that now. So we'll generate predicted x's. We'll do create new x's. And this is marked down. So we'll say x underscore new is going to be equal to np.linspace. and I want to have points between 0 and 80. And we only need 2 points because we're dealing with the line here. Now you may ask why these numbers in particular, why choose 0 and 80? So again, keep in mind that what I'm doing here is I'm going to use these x's to generate a line. And this can be used to see how well our model fits our initial data set here. Our initial data set went from 5 all the way to 55. So I chose 80 because it's just a little bit outside of that range, and you can kind of see it working. For example, I would not want to choose 1,000,000 because if I did, the initial data set would be so small you can't even visualize it, right? So I'm choosing numbers that just play nice with our initial data set. All right, let's go back. So that will represent our new x's, and let's run that. No issues there. Oh, and yes, we do have an issue. Let's see. Oh, I forgot space. So this is linspace. Linspace. Let's see, what's it complaining about? There we go, typo. All right. So now that we have those new x's, what we're going to do is we're going to take those new x's and then use them to generate y's. And these are our predicted values for those x's. So we'll do, make this markdown. And we'll call this generate predicted y values. And for this, what we'll do is we're going to actually use our model. So we'll do y predicted is equal to our model dot predict. And here we're going to pass in our x's, so our new x's. And let's see, let's run this and see if we have any errors that pop up. Okay. Actually, you know what? I'm forgetting something here. Yes, I'm forgetting something. So just like how we did this before, remember how we reshaped our x's with our original data? We did that here at this step. We have to do the same with our new x's as well. If I don't do that, then Scikit Learn is going to complain. So before I can actually generate my predicted y values, I'm going to reshape x's. So we'll do make this markdown, and we'll do reshape x values. And then here we're going to do x is equal to x dot reshape, and we're going to pass in the tuple of -1 and 1. Okay, so we have that there. Now let's try to do our predicted y's and see if that complains. And yes, it does. So I may have a typo again. Let me look to see what I did up here. Okay, I see. So it's funny. What I should have done is use x new. So I'll do x new here and run that. Okay, that ran. All right, no errors, perfect, good. So now that we have our predicted y values, the next step is to visualize this. So as I said before, what we're going to do is we're going to make two different plots. The first plot, we're going to have the original data, and that's going to be a scatter plot. And then the second one, which is our predicted values that we have here, we can do that as a line. So let's plot some stuff. So plot data. Okay, so let's see. We're going to do our, as I mentioned before, this is for the original data. So we had X's and Y's, and then for the predicted data, the ones that's supposed to match the original, we're going to do this as a line. So we'll do plot X new, and then Y predicted. And let's make this color different. Let's make it red, so it sticks out. Okay, and what else? So let's show the plot. So we'll do plot.show to actually see the output. And let's run this. All right, perfect. So as you see here, we have the original data, which is in blue, right? That's the scatter plot. And then we have our predicted values, which is the red line. So keep in mind, the reason why this fits so well is because we're using linear regression, and this is the actual predicted data. One of the cool things that we see here is that we can do extrapolation, meaning that our original data set, I think, went from 0, X was 0, all the way to 55, right? And here, by using the predictive values, we can actually extrapolate or go outside of that zone. So we can actually see what we would have for Y if we had a value of like 80. So that's essentially it. So hopefully you guys can see how to use Scikit-Learn to do linear regression. Recap is that we first created our data set. Once you had our data set, we then use our model to predict values of Y's given certain X's. And then after that, we just plot that on our graph, and voila. In the next video, what I will cover is how to do the same thing that we did here, but instead of with a single variable, we'll do it with multiple variables.